Here's a radioactive decay example. The nice thing about this is that it follows first-order kinetics, so we're just going to break out all of those integrated rate laws we learned at the very beginning of this semester. For example, the half-life of polonium-210 is 138.4 days. How much of a 1.5 milligram sample would remain after 2 weeks? Well, the first thing we need to figure out the rate, because I didn't give you anything about the rate constant. So that comes from the half-life equation. Half-life is natural log of 2 over k. So if we rearrange that, k is equal to the natural log of 2 over the half-life. So that gives me a rate constant of 5 times 10 to the negative third days inverse, right, because this was in days. Now we're going to plug into our integrated rate law for first order and solve for n at time t. Now I need to make sure that the time matches, right? This is in days, this is in weeks. So either convert days to weeks or weeks to days, whichever you prefer. So here's my first order integrated rate law. This is my initial amount. This is the amount I'm solving for. I converted weeks to days. Okay, so 2 weeks is equal to 14 days. So that's why this stayed the same and this became 14 instead of 2. If you plug in 2, your answer is going to be off because weeks and days won't match. Then we just do a little bit of arithmetic, right? Natural log over 1.5 over x is equal to, this reduces down to 0.0702. To get rid of the natural log, we raise both sides to the e. So 1.5 over n is equal to 1.07, which means that I have 1.40 milligrams remaining after 2 weeks. That makes sense, right? Because the half-life is 138 days. So we've only been going at it 2 weeks. So you wouldn't expect the mass to go down by a large amount, and it doesn't.